Hello! This presentation is about the mass spectrometer by Curtis, Sam, and Nish. Here is some basic information about the mass spectrometer. A mass spectrometer is a device that measures a chemical in a sample. It does this by measuring the mass-to-charge ratio of gas phase ions. In order for a sample to be tested in a mass spectrometer, it needs to be a gas. To put it in simple words, a mass spectrometer is used to find mass. And once the mass is found, you are able to determine the chemical makeup of a sample. It has helped decrease the amount of time spent trying to identify an ion through its weight alone, as it took far longer to find out the weight before the mass spectrometer was invented.
Here's some historical information about the mass spectrometer. The idea of the mass spectrometer was first thought of in 1886 when scientists by the name Eugene Goldstein first discovered Canal rays, positive ions that were created by certain types of gas discharge tubes. This was furthered in the 20th century with the discovery of isotopes in 1913 by J. Thomson, whose student Francis William Aston built the first functional mass spectrometer in 1919. He used it to identify isotopes of chemicals such as bromine and chlorine. Most scientists began to use the mass spectrometer as the 20th century continued, as it was able to find finite amounts of particles and isotopes. Modern techniques of mass spectrometry were devised by Arthur Jeffrey Dempster and F. W. Aston in 1918 and 1919 respectively. Mass spectrometers are now very common throughout the world.
I will now explain to you how a mass spectrometer works. A sample is ionized by removing one or more electrons. They are then sent through an ion-accelerating electric field with small slits in it. This process is referred to as the ion accelerator. This process happens in a vacuum so that the ions are not affected by molecules in the air. After they are made into ions, they are sped up and put in a straight line. In this area, the ions are run through a magnetic field and an electric field. This is done so that the ions are not traveling at exactly the preferred speed, are brought out of line by either being too attracted to the magnetic force or the electric force. This process is referred to as the velocity selector. Following this, the ions are sent towards an electromagnet. As the ions pass by this electromagnet, they are deflected due to the positive charge of the ions being attracted to the negative charge of the electromagnet. After the charges have been deflected, they head towards a detection plate, where the ions hit the detection plate and cause a current to be sent. This process is referred to as the separator region. The current is used to sort the ions according to how much they were deflected by the electromagnet. The ions with the greatest mass and the smallest charge are the ones that deflect the least. These results, along with the mass of the ions, are used to determine the mass-to-charge ratio of individual ions. These are then plotted to determine how many of each ratio is in the sample of the gas. Based on these results, you are able to determine the chemical makeup of the gas and what the gas is identifiable as. A mass spectrometer consists of three parts: an ion source and accelerator, a mass and velocity analyzer, and a detector. An ionizer is also a part of the mass spectrometer. It is used in order to convert a portion of the sample into ions. There are different ionization techniques for different phases of a sample. These phases are solid, gas, and liquid. and the efficiency of the technique used on them differs from sample to sample and phase to phase that they are in. An extraction system removes ions from the sample, which are then accelerated through the mass analyzer and onto the mass detector. The different masses of the fragments allow the mass analyzer to sort through the ions with a mass to charge ratio. This is also where the ion speed is achieved, and electromagnets are used to ensure the speed is the same for all ions. The detector then finds a value of the indicator quantity and is able to provide data for calculating the abundances of each ion present. It is important that the ions produced in the ionization chamber have a free run through the machine without hitting the air molecules. To ensure this, the whole process happens in a vacuum.
The results that you receive after using a mass spectrometer are in the form of a bar graph. Originally, the mass spectrometer records the distance that the ion was deflected by the electromagnet. Based on this distance and knowing the charge and velocity of the ion, you are able to calculate the mass-to-charge ratio for all the ions that are coming into contact with the detector plate. The graph that the mass spectrometer outputs compares the mass-to-charge ratio of the ions and the relative abundance of ions found in the sample. Scientists have already taken the mass-to-charge ratio of almost all the elements on Earth. Based on these pre-recorded numbers, you can quickly determine the identity of all the ions in the sample that you are analyzing. This is useful as you can see the percent of a sample that is comprised of a particular element based on these relative abundance readings from the mass spectrometer. To help you visualize what is happening in the mass spectrometer, we have created this demonstration. Imagine it like rolling a plastic ball, a rubber ball, and a baseball down a slope, and then deflecting them with an air blower. As you can see, the plastic ball was the lightest with a mass of 15 grams, the rubber ball was in the middle weighing 41 grams, and the baseball was the heaviest weighing 145 grams. In our demonstration, the different balls represent different ions with different masses. The hill represents the accelerating field, and the air blower represents the electromagnet. As the three balls roll down the hill, the plastic ball is deflected the most, the baseball the least, and the rubber ball is between the other two. Assuming that in the demonstration all the balls have a similar charge, this shows that the ion with the highest mass-to-charge ratio will be the one that deflects the least.
An electromagnet is a coil of wire that acts as a magnet when an electric current passes through it. Electromagnets play an important role in a mass spectrometer. Electromagnets are used over permanent magnets for their ability to be able to manipulate the strength by adjusting the flow of electricity. Electromagnets have two main uses in the velocity selector and the detection chamber. In the velocity selector, a magnetic field is produced to make the charge go in a straight line, countering the electric field. Electromagnets are also used for the detection chamber by producing a magnetic field. The ion that has entered the magnetic field will be forced to travel in a circular path, hitting the detector. Then, by measuring the radius and knowing the charge, magnetic field, and velocity, you will be able to find the mass.
You can use the mass spectrometer in many ways. The mass spectrometer has qualitative and quantitative uses. Some of the more common uses are as follows. You can use the mass spectrometer to find environmental toxins. Industries, governments, and regulatory bodies need efficient ways to test the purity of our water, the cleanliness of our air, the content of our soil, and the quality of our food. So, by using a mass spectrometer, you're able to find what chemicals are present. For example, an investigation by the Associated Press has shown that a wide range of pharmaceutical products, including antibiotics, mood stabilizers, anti-conversions, and sex hormones, have been found in the drinking water supplies of about 41 million Americans. It can also be used for exploring things in the universe. Two primary applications for the mass spectrometer in space are A. Analyzing the composition of the planetary atmosphere, and B. Monitoring the air quality of the manned space flights. The Cassini spacecraft contains the Cassini plasma spectrometer, which is used to measure the composition of ionized molecules originating from Saturn's ionosphere and its moon Titan. Air quality and composition inside the manned shuttles is closely tracked by NASA for the safety of the astronauts who are on space mission. Other more common uses for the mass spectrometer include the breath analyzer, and it can also be used for finding performance-enhancing drugs. It is also used by the police forces to identify the substance found in the crime scene.